Morning, good afternoon, good evening, and welcome to our webinar, Becoming the Defender of Assets. My name's George Williams. I'm the founder and CEO of Reliability X. I'll be your host today. A little bit about my background, maintenance and reliability for quite a long time, 25 years at this point, most of that in pharmaceuticals, but we're not going to spend a lot of time introducing ourselves. You can look us up on LinkedIn, connect to us, would be very happy to connect. So our assets are in trouble. Most of the facilities that we either tour or get engaged to take a plant tour, or whether it's production or facilities or utilities management, I have to say that a vast majority of those are not what I would consider to be in fantastic running order. And our assets are aging, our infrastructure is aging, and we have to be able to manage that as an organization. So let's take a deeper dive into some of that. Troubled assets are assets that typically are either not getting the proper preventive maintenance, or the PM is not very effective, or they're potentially aging. So a lot of organizations have infrastructure that is aging and well beyond the financial benefit of replacement, and should be on target for a capital replacement strategy. However, lots of organizations, specifically in today's climate, are looking to kind of stretch that out because finances are tight. Costs are going up, lead times are increasing, and so there's a lot more demand for product. And so there's not a desire to invest and replace the assets. And so we tend to be asked to force these assets to survive longer than their expected life. From a maintainer's perspective, the skills are disappearing. At least I know for sure in the United States, and certainly throughout Europe, most of the world today, the skilled labor resources are disappearing. And the ones that do exist continue to bow out poor leadership by band-aiding things and getting things to run, and not necessarily having the opportunity to take care of things right the first time. On the operation side of things, the operators are typically not trained well enough to spot defects. And our operators tend to be taught only how to turn the machine on, do changeovers, and let it run, but don't spend a significant amount of time ensuring that the asset is healthy. And from a leadership perspective, the goals such as reduce cost create poor behaviors, where we either put poor incoming raw materials through our production lines, and or buy cheaper than optimal parts for our assets. And so we don't get the life we expect out of them. All of these challenges are the challenges that the maintenance organization has to face on a very regular basis. And as I'm sure everyone can attest to, assets that are neglected don't perform as well. We see larger downtime associated with those assets. Those assets have center lining issues and issues from an operational perspective, where they jam or clog up or plug up. They have controls issues where we're not analyzing that data and making adjustments accordingly, or the center line has taken us out of the ability to run effectively. On the facility side of things, that aging infrastructure creates risk. If we're in, something like public utilities, we end up with risk because certain assets are down. It's tough to get the parts, and we're rush ordering things, and all that makes our costs go up and our performance go down. And so we have to be able to address these factors as an organization and understand the value and benefit of operating reliably. When we think about how we're going to defend the asset, we first have to understand what the role of the maintenance organization is with respect to risk management. On the screen, what you see currently is a representation of the bathtub curve. And on the left-hand side, we have early wear out or infant mortality failure rates. These are components such as electronic components that weren't benchtop tested, things that were warranty items, things that didn't get installed correctly, things under pipe strain, whatever the installation process was that did not ensure the reliability of the asset. On the right-hand side, we have wear out or end of useful life. This failure pattern is related to both components and assets that have successfully made it to their end of useful life. And so, if your bearing is actually seeing its L10 life, that would fall into this category. Everything in between is a random event. And the reason we say it's a random event is because it hasn't survived its useful life. And if I install two pumps side by side and run them equally, they will not fail on the same day for the same reason. It is very low probability that that occurs. And so these events are random in nature. When the organization decides to purchase an asset, that asset has a very specified base condition. We can buy an asset, let's say it's a vehicle. We can buy a Toyota Corolla, or I can buy a Jeep Wrangler. And they have a very different expectation of reliability. Baked into their design is the cost to operate and maintain the asset. The overall cost to operate and maintain the Toyota Corolla is lower than the overall cost to operate and maintain a Jeep Wrangler. That's not to say the Jeep is not a viable car. It just means that baked into its design is a different expectation of cost and a different achieved or designed in inherent reliability. The maintenance organization's role is to manage deterioration. It's to guard and protect the asset from impending failure. And so our preventive maintenance program is designed to mitigate deterioration. What you see on the screen is a sawtooth pattern. As over time the asset deteriorates, the maintenance organization takes an intervention and restores it back to base condition. Over time, it deteriorates again. The maintenance organization replaces some belts and it goes back to base condition. Every time it needs lubrication, we restore it back to base condition. This happens over and over throughout the life of the asset. On the underside of the asset's deterioration is the cost to operate the asset. As deterioration happens, the cost goes up. So as I create friction in my bearings just before I lubricate, I'm using more energy to operate the equipment. When I restore back to base condition, I lower back to base operating cost. Again, this happens over and over throughout the life of the asset. We utilize techniques such as design for reliability to raise our base condition. And we utilize techniques such as reliability-centered maintenance or failure mode and effects analysis to stretch out the deterioration rate. So for example, if I utilize techniques like design for reliability, I can increase the inherent base condition of my asset. If I change my motor bases from the type that use two pieces of all thread, which are very difficult to align, to the type that has one adjusting nut and two rails, the unit will always be in alignment. And so I don't have to check the alignment as often. The only time it would be out of alignment is if the sheave moves. And so I change the base expectation of reliability. If I utilize techniques such as automatic lubricators, I stretch out the frequency at which I need to do the PM and I change the time intervals at which I need to restore back to base condition. And so through these techniques, the maintenance organization not only can alter the, or at least recommend from an engineering perspective, a different base condition, but through uses of techniques such as reliability-centered maintenance and failure mode and effects analysis can begin to stretch out the frequency at which that deterioration happens and minimize the number of interventions required to restore back to base condition. Eventually, however, we're definitely going to have a failure. In this case, our bearing gets contaminated. And so we have the beginning of the PF interval. We utilize predictive maintenance technologies to identify when that PF interval has begun. And so whether we're using vibration analysis or ultrasound, we spot that this bearing now has a defect. The reason we use the technology is not to stop the defect from happening. It's already there by the time the technology sees it. We utilize the technology so we can have a maximum planning window to allow us to get the parts ahead of time and do the intervention when it is least inconvenient or most convenient for the operation. And so, if we know in advance that this bearing is going to foul, we can coordinate with operations when it is most convenient for them for us to take the asset down and replace the bearing. If we do not use these technologies and we rely on our senses, we have the potential to have the catastrophic event. Using our senses and risking the catastrophic event is what we call reactive maintenance. At this point, we are reactive in nature. When we do the repair, it is not likely to be convenient to the operation, and it is likely that we will have to rush order parts. Not only will we have to rush order parts, but it is likely that this bearing, because it now has catastrophically failed, it is likely that there are other parts that are now damaged, whether it's a roller or the shaft or the pillow block. We're now spending a significant amount more to take care of the asset. So, the purpose behind the maintenance organization is to manage risk. It's to manage the cost and risk balance between operating effectively or being reactive. If we have effective PMs, they typically inspect or replace wear components. The preventive maintenance purpose is to identify failure modes that can be addressed or assessed for condition and then inspected and where components be replaced. They address failure modes. If you own a vehicle this morning, whether or not you walked around the vehicle, checked the left blinker, checked the right blinker, checked all your fluids, is not likely that you did these things. The reason you did not do these things is because in your head, you've identified what's called a risk priority number. You've decided it is not worth the time, effort, and cost to do all of those minor inspections before operating your vehicle because the vehicle's design has reduced the risk priority number. You don't have to check your tire pressure because there's now an alert that takes place in the cabin of the vehicle that tells you your tire pressure is low. And so the car manufacturer has increased what's called detectability. And so we don't have to do those inspections. Your assets at the plant are very much the same way. If you have added alarm points or are taking vibration analysis readings or ultrasound readings, the physical intervention task that the OEM manual is asking for may not be necessary. If the failure mode is being addressed through vibration, let's say it's coupling, and currently your PM has a inspect the coupling task. If you're taking vibration readings, that is the inspection. And so you should be removing the task inside your PM to inspect the coupling physically. This is how the maintenance organization becomes more efficient and does not have to interrupt the operation. We utilize these technologies to take advantage of being able to assess the condition of an asset while it is running whenever possible. This increases the availability of the asset and allows production to continue. If we are not PMing things appropriately, or potentially the organization tells us not to PM it, you're not allowed to have the asset. In the event that the organization is telling you you cannot execute the PMs, there's usually a couple of reasons. One is they may not have any faith that the PM is effective. And so we have to make sure that our PMs are effective and that they address actual failure modes. The other issue is, quite honestly, you should not own PM compliance. And I know we're going to get a lot of pings and questions on this one potentially, but you don't own the asset. It is not yours. And so think of it like this. If you own your vehicle, it is not the mechanic's responsibility to remind you to change the oil. It's not their responsibility to schedule your oil change. You're the operator and the owner of the vehicle. It is your responsibility to ensure that the oil gets changed. It's the mechanic's responsibility to do it correctly. That is no different in your plant. If you own the asset, you could shut it off. You don't get to shut it off, it's not yours. And so, whether or not the PMs get executed, we should be trying or attempting to transfer that ownership where it belongs. Operations should be on the hook for PM compliance. The other potential option is to take a stand. You can utilize what we call a permission to fail form. I'm going to attempt to bring that up on the screen, and hopefully you can still see my screen. This is a permission to foul form, and it's really just a basic form that says, hey, we tried to come out and do a PM, and operations is telling us we can't have the asset. That's just fine, but the risk of that asset now falls on you. Please tell me when I can do the proper PM. And so we're going to make this form downloadable, available at our website, hopefully later today. So if you're interested in a permission to fail form, you can either email us at ask@reliabilityx.com, or you can download it later when we get it up on the website. Let's get back to our regularly scheduled program. So we're going to transfer ownership back where it belongs. Think of it like this. If you're the owner of your house, if the roofer shows up to your house and just starts ripping shingles off without your permission, you'd be a little angry. As the owner of the house, it is up to you to make decisions on whether or not you should replace the roof or not. If you wait until the roof is leaking and water is coming into your home and creates other damage, it is not the roofer's problem. It's your problem. You're the asset owner, your operations in that case, in that scenario. And so we have to transfer ownership back. Maintenance's role in understanding the backlog and conveying information to operations to make decisions is a conveyance of risk. What happens if we do not do the PM? What happens if we do not do these repairs? It is still up to operations to prioritize which work will and will not happen. The issue we tend to have in our industry is that operations today gets to tell you, no, we're not doing it, but then they own none of the risk. When the asset fails, maintenance's phone rings. We have to be able to have a conversation that transfers that ownership where it belongs. Your role is the conveyance of risk and the high quality execution of the work once it is determined by operations that the work should happen. And so that may not be the position you find yourself in, but it's about time we defend our assets and put the onus back where it belongs. The next issue, lifespan of the asset. Well, assets have a specific lifespan. When the value proposition is such that it costs more to operate and maintain than it does to replace the asset, well, it's time to replace it. And lots of folks feel like they're heroes being able to band-aid the equipment. And I get that. Being an operator, being a maintainer myself, you take a lot of pride in being able to step back and say, I got it running again. And that's a heroic thing. At the same time, once the asset is to a point where it's a nightmare for the maintenance organization must be able to convey that risk outside of just their opinion. We have to document things inside the CMMS, and we have to be able to show the cost benefit analysis associated with replacement or repair. There's lots of math on that. We don't have enough time in this webinar to review all that. Maybe we'll do that in the future as a specific topic. But the repair versus replace decision is a math decision. And so we should be conveying when it is no longer a beneficial asset and requiring our finance teams to do the right thing. In some cases, we're spending an awful lot of time that could be used to make sure the plant is running on eBay searching parts. While I recognize that you may be in a position where you have an outdated asset and you have parts that are no longer available, that you have no choice but to try to find these things on eBay, Every time you actually find one, you are not helping the organization. The organization is staying at risk because as long as you're able to do this, they are not replacing the asset. And the asset, obviously, at this point needs to be replaced because you're creating a significant risk. In the event you are unable to get these parts, what does the company do? Eventually, they'll have no choice. They will have to replace the asset. We might as well get that ball rolling sooner than later. So, who's going to do all this defending, especially in today's climate? I think one of the issues we're all facing right now is that folks are leaving. The skills trades organization is disappearing. And unfortunately, the only thing heading towards the jobs are people that are less qualified. At least in the United States, we're having an extremely difficult time finding skilled labor and filling these positions. I taught a class very recently, and there was a reliability engineer in the class who quite honestly, has no background in maintenance and reliability, and I, you got to question. Well, we've got to get this person trained, and we've got to get them to understand what the process is and how to add value to the business. And self-admittedly, they feel lost. This is not uncommon down at the skills trade level, where we have folks that journeyman mechanics and journeyman millwrights that are leaving companies and they're being replaced, and the requirements of hiring are getting lower and lower because they have to. If we don't find any candidates at this level, then we have to lower our requirement. And so we begin to lower the skill level that we will accept into the plant. That's a very dangerous position to put ourselves in, but it's the scenario we find ourselves in today. And because that skilled labor is leaving, we have to do something. And that do something is really kind of twofold. We have to lower the necessity of the additional skills if possible. Through the next generation of our assets, they have to be easily maintained, not because it's just a efficiency like it used to be. We want maintainability to gain efficiency. It's now we need maintainability because the skill level will not exist to do very comprehensive troubleshooting. And so the design for reliability and design for maintainability necessity is not just now a convenience of the maintenance organization. It's almost a requirement, because if we don't, for lack of better terminology, dumb down the equipment, we're going to be in a lot of trouble. So it's more critical because of that than ever to capture tribal knowledge inside the CMMS system. We have to be able to capture all of the data that currently exists and knowledge that already exists so that the next generation can be trained on, because they're going to be using their phones to figure out how to work on the equipment. Whether they're using their phone to go to YouTube or they're using their phone to go to your reliable data is going to be whether or not you actually get it in the system. It's not going to be reliant on the people in the field, because they're going to do this. They're going to look up how to do this, how to troubleshoot something, how to replace something. You will have either captured that information internal to your company, or they might end up at a YouTube video where somebody's telling them it's great to always put 5 pumps of grease in a bearing. And depending, what hit they get on YouTube is going to be what they learn, whether it's correct or incorrect. So it's on us to make sure that we capture that data and get it into the system. So we've got to be prepared, capture today's knowledge, and develop standards. Those standards are trainable, they're repeatable, and you can improve them if they're not working, or if you find another best practice. It's easy to update a document. It's very difficult to not have it and hope that the new organization coming in can be repeatable and reliable. We've got to design that new equipment, as mentioned earlier, for a lower skilled maintenance staff. And the other option is to create a spoken wheel approach to talent acquisition. So contact your local community colleges or technical colleges, develop a partnership, get your company to donate some money, and in exchange, have the access for top students. Lots of companies are taking this approach right now. You see mechatronics laboratories popping up inside community colleges all over the country right now that are being funded by companies so that the company then gets first pick of the students coming out of the courses. The next piece is operations has to understand they play a significant role in the reliable operation of our plant. It's not the mechanic's responsibility to make sure your car's oil's changed, right? It's certainly the operator's responsibility. And the operator has, in my opinion, the largest potential impact, both positive and negative, in how our assets run and how well they're maintained. If they are not kept in good condition, if they are operated beyond their design load or even below their design load, we lower the life expectancy of those assets. And the maintainer is not there every day to ensure those things. So the operator has to do it. The difference between a car that's currently rotting in a field and one that looks brand new is not necessarily how well the mechanic did. It's how well the operator took care of it. And that's not any different inside of our plants. The other piece from an operations perspective is that we have to understand where defects come from and who's responsible for their creation. Reliability is not just a maintenance initiative. Reliability is an initiative across the entire organization. For those that are in production, what the graphic we have on the screen right now is an understanding of manufacturing losses and where they come from. And if you've heard of OEE, overall equipment effectiveness, and you know that it is a calculation between quality, performance, and availability, the availability bucket is typically what maintenance is blamed for. We'll say blamed. If the asset's not available, we say there's a maintenance problem. And oftentimes, there are significantly other issues that exist in the availability bucket that are not maintenance related. And so an understanding of these losses, and certainly we offer classes that provide much more detail into this. In this webinar, we're not going to go through this in any significant level of detail. But an understanding of where these losses come from and which ones are the responsibility of maintenance and which ones are not is something that I would highly encourage folks to learn about and get a broader education on. For more information on how you can learn these things from us, you can go right to our website or ping us at ask@reliabilityx.com. So the operator is driving your expensive asset. Is the operator trained properly? Do they understand more than just here's how you turn it on, here's how you hit the run button? Because there's much more to understand in operating the asset. Do they understand the track? Do they understand the process flow of product through the line? Or if you're a process industry, do they understand the flow of product and how things happen? If you're in public utilities, do they understand the process that happens within that plant, whether it's water, wastewater, or energy generation? Those things are really critical. The operator should understand the business, not just the machine. Do they communicate to the pit crew? Do they let their supervisor know when something doesn't feel right, when it's not running right? They should have their pulse on the asset. And do they communicate even above just, the lead there or the supervisor, but to the production manager with an understanding of how the line's running and what issues they're seeing and what defects are occurring? It's really hard to make problems go away if all we do is continuously undo a jam. The jam will continue until we make it go away. When we can finally get operations and maintenance to understand both their roles and how to be effective, then we can have a reliable plant. And a reliable plant is clean, it's organized, it is safe. You will notice that it is a more relaxed environment. In a chaotic plant that is not reliable, people are running all over the place. And in a reliable plant, the reason the safety record is better, the reason it is clean is because the operation is running smooth and you have time to make sure that those things happen well. A reliable plant has a rhythm to it. You can hear it When you walk through a plant that's reliable, you get a very repetitive sound. And in a plant that is chaotic, those sounds are happening all over the place, and it has no rhythm. A reliable plant produces quality. An outcome of reliability is quality. And so focusing on reliability will certainly help your quality metrics. And a reliable plant is profitable. It's a balance, again, between risk and profit. And we don't want to spend more than it takes to be as profitable as we can, but we can't spend less, right? You're either going to spend what it takes to receive the maximum value from an asset, or you are going to spend less and get less value. It's really all there is. You could spend more and waste. So there's three real options. That's it. I can spend more than I need to achieve the value of an asset, in which case I have waste. I can spend precisely what it takes to receive the maximum value from an asset, in which case I'm reliable. I can spend less than it takes and not get the value from the asset. That's it. There's not a lot of choices here. So in order to maximize that value, we have to remove defects. In order for us to spend less to operate, I have to get rid of the bugs. And so one of the ways we can do that is look inside the CMMS, especially on the operation side, and look for all the work you're doing currently where no part is replaced. Oftentimes they are operational issues, things that a standard and training can help mitigate. Look inside your SCADA system, or if you're not in production, look inside your building automation system, your Delta V system, and look for reoccurring issues and make those problems go away. If you don't have any of those things, you can still do the most basic thing, which is listen. You can listen to an operator, you can listen to the maintainers, you can listen to the assets. They are all talking, and if you build relationships and listen, you'll know what to improve. Everybody who's in the role of reliability or maintenance management, the easiest way for me to term what your job is to make everyone else's job easier. And so if what we're doing is not making their job easier, then we are failing. Our role is to make the maintainer's job easier. It's to make the operator's job easier. And we do that by eliminating nightmares and headaches and things that are inefficient and things that just waste time and money. So we've got to defend that plant. We have to have an effective strategy in order to maintain those assets. We've got to hold people correctly accountable for their role in reliability, whether they are an operator or a maintainer. We have to develop standards so we can drive improvements and create the ability to train people and increase their education level. We have to eliminate defects. We have to listen to our assets. And most importantly, we have to take action to improve. So just a couple quick things. This is all part of a broader asset management strategy. And the asset management strategy is nothing more than a plan, or asset management system is nothing more than a plan, do, check, act cycle, where we align to business goals, develop a strategy, understand our asset portfolio and how it achieves our goals, identify and create the strategy at the asset level on how we will operate and maintain it, manage the work to operate and maintain it, analyze the available data, and then in the adjustment section or act section, we eliminate defects and change our strategy accordingly as the business changes. And so this basic asset management system is how we manage and govern everything in our space. So a couple quick notes, please don't disappear just yet. You can earn your certificate in maintenance management if you happen to be in the United States or want to travel to the wonderful city of Allentown, Pennsylvania. This is our upcoming course schedule. This is available. Just go to LinkedIn. You'll see it as one of our posts, or you can go to our website and see our upcoming schedule of classes. You can email us at ask@reliabilityx.com or go to 877-RLBLTYX or write to our website. There is a webinar evaluation. So while I'm asking the questions, if you don't mind, you can scan the code on your screen right now. The webinar code, when it asks you for it, is 2024_4. And this will allow you to do a review of the webinar and give us feedback. We're going to be doing webinars all year long, every Thursday at 11 a.m. Eastern Time. And your feedback will help us tailor what you're looking for, what we should change, what the format's like. So please take a moment to fill out the evaluation. We would much appreciate that. In the interim, it's time for us to start answering some questions. So, is traditional preventive maintenance effective to actually identifying problems and good use of resources? Is there a trend to change to condition-based maintenance and planned maintenance? Thanks for the question. That's a great question. I think there's room for both. There are assets whose failure modes are not detectable through what you would consider to be a technological condition monitoring technique or a predictive maintenance technique. And so there are certainly applications um, where I guess I'm really conflicted here. Let me just answer it correctly. All PM that results in the replacement of a wear component is in fact condition-based maintenance. If I inspect the belts and determine that the belt needs to be replaced, it's condition-based maintenance to replace the belt. The difference is the PM is doing the inspection versus a technology. So in predictive maintenance, you're using a technology to do the conditional assessment. The execution of replacing the wear component is happening because you assessed its condition. So even PM, unless it is a time-based replacement, is condition-based maintenance. Now, if I have a 3-month PM that says, I don't care what the condition of the belts are, we're going to replace them, then it's no longer condition-based maintenance, it's time-based maintenance. So it's, I think there's room for both in terms of what the strategy is, and it would be asset dependent and failure mode dependent, but great question. What methods have you found that were effective in changing from reactive to proactive within management team? First and foremost, analyze some data and find out why you're so reactive. It is likely that most work that happens in your plant is repetitive. It's not new. It's the work orders that come into the system are not something where you go, wow, we've never done that before. They happen over and over again, some more frequently than others. Figure out what work you're doing most frequently, go through a root cause analysis process, eliminate the defect, and then report back to your management team what you did and what it saved the company. Because it is a savings, it's a future cost reduction, right? You're not going to spend that money. It's a cost avoidance in the future. Start documenting that. And as you do that, you'll get leadership on board more, and you can demonstrate, look, we used to have this issue once a month, and then we did this work, and now I haven't seen the issue for 6 straight months. That tells a story that leadership can understand, and they can put dollars to and understand. So we typically see being reactive as this big mountain that's impossible to overcome. But the reality is it's made up of really small problems. And if we eliminate those individual small problems, then we become more and more reliable. Can new technology and field sensors properly installed replace low skill or need for additional headcount? I'm always, it depends on how automation is used. For example, if I put in a bunch of automation where the alarm point just shuts the equipment off, I didn't help. If I put in automation, let's say I decide to replace somebody who puts boxes together and palletizes, and I put in a palletizing robot and a case erector, somebody still needs to feed the cargo and the case erector, and now I need a more skilled person to take care of the robot. So there's this perception that it's going to get rid of a bunch of headcount, and I don't believe that's the case. I believe there are certain things where automation makes a lot of sense. I've got an agricultural client now where they have a shaker on top of their scales to feed product in. And then further downstream, they have a check weigher that's telling you if it's overweight or underweight. In my opinion, based on how much you're vibrating, the check weigher could adjust the vibration Am I seeing too many overweights? If I'm seeing too many overweights, then slow down my vibration. If I'm seeing too many underweights, speed up my vibration. That's a great use of automation that makes the plant more efficient and saves money. It's not really about headcount for me. I don't think you're getting rid of the headcount. Hello, as the new maintenance manager in an organization without a dedicated leader for the role, in the past 3 years, I faced challenges with outdated equipment, lack of effective preventive maintenance, and a team accustomed to being reactive. How can I effectively shift our maintenance strategy towards proactive and reliability while aligning with the existing organizational culture? Um, well, you're not going to like this question. I would assess what you think the probability of success in that role is. And if you don't think it's successful, I would start finding another position. We can either push the boulder uphill, and we can teach you all kinds of ways to talk to leadership, but that doesn't mean they're going to make good choices. And there's a reason you keep going through a leader. It's because something else is happening at an organizational level where those folks don't want to stay. And while you may not like my answer to you is put yourself in a position for success. If you're consistently pushing the boulder uphill and have marketable skills in today's climate, you'll find a great position with a company that has the culture you're looking for. If you're trying to shift the entire organizational leadership, you have a challenge ahead of you that will be very stressful. And you can win that challenge, certainly. And there's lots of ways to do that. And we have a bunch of webinars coming up that actually address some of these things. But at the same time, you have to figure out what the probability of success is in that role. What I'm working on to share the ownership of maintenance KPIs with let's see. What I am working on to share the ownership of maintenance KPI with operations by getting operations manager to approve the PM schedule, keeping the asset owner is operations. That's right. Maintenance are working with operations to ensure the equipment are reliable and available. However, it is still a debate as senior management stating the ownership of the asset reliability solely under maintenance. That's great. Just ask them the question, does your mechanic own your car? You gotta ask simple questions. And I would literally bring a slide up that says, who is responsible for ensuring the oil gets changed and who is responsible for changing the oil, and put the asset owner and maintenance on there and see what happens. If you own the asset and leadership is telling you you own the asset, go shut it off. In the middle of production, shut it off and tell them you're doing the PM, and then you'll find out really fast if you own the asset. Why do operations not getting that first line maintenance operator task? How to get them to own it. One of the right way to get a cascade top down. This is a big challenge. So this is about how do I get the operators to take on tasks? And there's multiple challenges there. Some may be that from a union perspective, you may not be allowed to give tasks to an operator. Really depends. I would suggest that you find a champion, find one operator, find one line or one machine area that you think you have somebody that you can train as an operator to take on some tasks and to develop a cleaning standard and to make sure that this shift sets up this shift for success. The trouble is, as maintenance, we don't own the responsibility of operations, and the leadership of operations may not be on board with that. I would suggest you teach somebody on the operations side about manufacturing losses. You can certainly find out more through us about how to train those folks. There are lots of webinars coming up. Look at that schedule. It's a huge schedule, and potentially educate people. It's all about educating people and empowering them. Is risk-based criticality assessment the only way to categorize the equipment and instruments? Um, I might need a little more information on there because I can categorize equipment as this equipment's blue and this equipment's red. So no, risk-based criticality is not the only way to categorize equipment, but I'm not quite sure of the full question. So Aswin, if you could please give me a little bit more info, that would be great. How can you justify the importance of asset hierarchy to upper management? The importance of getting it into the system comes down to being able to analyze data. And without that data, you can't make good choices. So I would again ask simple questions. Why does finance need an ERP when they can use an abacus? Why does finance need to know cost centers? Why can't they do without having cost centers? Well, because they have to know where the finances go from a tax perspective, because every cost center has different tax implications. There's lots of reasons. And you need an asset hierarchy so you can know which types of problems you have to solve and where the money is going so that you can make replacement strategies. It's not any different than the ERP in finance. Bring your question down from a technical level and ask it in terms of a reference that the leadership is already familiar with. Asking you to do without an equipment hierarchy is the same as asking finance to do without cost centers. Risk-based, it's time consuming to do risk-based analysis. Thank you for the follow-up. Um, yes, yes, it's time consuming. I don't, it, the only way to get it done is to get it done. If it's a matter of resource availability, then I would suggest you find a way to gain some efficiency and transfer a resource to help do that and facilitate it. Yes. The other thing is to, if you can look at history of the work order system and see where you've had critical assets go down, and yet in the same week you were working on non-critical assets, or you canceled the PM because you didn't know it was a critical asset, try to figure out a way to cost justify going back and asking for the resources to get through the risk-based criticality analysis. A link in the webinar recordings would be appreciated. Okay, yeah, we'll send you some resource links. Thank you for mentioning that. When to use run the failure strategy in maintenance management, when it is cost effective to not do the maintenance. So if you have a home that uses a radiant hot water system, you have a fractional horsepower pump, and you're putting oil in it because in the middle of winter you need it to run. At your plant, a 1/16 horsepower pump is not likely to be cost justified because for $200 you replace the whole thing. So why would I send somebody out on a regular basis to oil it that costs more than that over the course of executing it only a couple of times? So it's a cost benefit analysis, just like anything when going through an FMEA and you get down to what the failure mode is and the potential ways to mitigate the failure mode. It's a cost benefit analysis. So once it is no longer cost beneficial to execute the work, you don't do the work and the assets run to fail. Awesome. Well, oh no, I got a couple more. One more. Maintenance 4.0 is based on data-driven maintenance. Please brief a little if time allows. Maintenance 4.0 is data-driven maintenance. I think all maintenance should be data-driven maintenance, and I don't know that we have to wait for maintenance 4.0. We've been doing data-driven maintenance for a really long time, since the 1960s, if you've been an early adopter to approaches that use data. I guess what we're asking about is things like machine learning. And there's lots of opportunity on the machine learning side where we're looking at parameters and doing regressive learning. And saying, hey, we ran well during this period, but we had an issue here. And then the AI, the agent begins to learn what the patterns look like before a specific failure. I think that's great, but they still don't, all they do is give you a maximum planning window. They don't stop the failure. You still have to remove defects and identify defects and identify recurring issues. So maintenance 4.0 is like taking predictive maintenance and moving it earlier. And if my vibration readings already give me plenty of enough time to properly plan and schedule and execute work, maintenance 4.0 is just giving me a larger window. It's not stopping the bearing from fouling. Oh, on a greenfield project. So if you've not up front, it says this task is for a greenfield project. That's in reference to the risk-based criticality analysis. This should have been part of the scope of the capital project. It is likely either it was not, or it was removed because of budget. In either case, um, the critical nature and requirement, I would say, helps drive your spare part analysis to determine what you should and shouldn't stock. And without it, you may overstock and spend more money, right? You've got to convey it in a way that leadership will be on board. Remember what your goal is. Your goal is not to be technically right, it's to get what you're looking for. And if what you're looking for is the money and resources to get the criticality analysis done, you have to convey it back to leadership as to why it's a terrible idea not to do it. And so you've got to think of what those ideas are. And in some cases, you're going to be ordering a bunch of spare parts to go in a storeroom for this greenfield building. And you can minimize that by doing the criticality analysis and not buying a bunch of extra parts for the stuff that's not critical. So there's a bunch of money tied up in, I've got to get my first set of spares. And so one of the ways you can tell them that is a necessity also is that you want to make sure that you start PMing that equipment that's critical as soon as it gets installed, and not wait till the project is finished and somebody's cut the tape, because those assets are going to start deteriorating over time long before you're actually in production or utilizing the facility. And so you want to make sure that you assess criticality so that you can get the PMs for the critical assets in the system early enough to start PMing them before the building is turned over. So that's just a couple of ways, but I would say, think about a few ways that you can project back to leadership why it's a silly idea not to do it. Okay, that takes care of all the questions. Thank you so. Oh my goodness, we went way over. That's awesome. Thank you so much. I hope everybody filled out the evaluation for the webinar. I appreciate it very much. You guys have a fantastic day. We're going to close out now. If you have any additional questions, you can email us at ask@reliabilityx.com. Thank you so much. We'll see you again next week.